Is Kingsley, and today I'll be going over how to sketch and analyze direction fields.
All right, let's look at example A. Sketch the direction field for the differential equation y prime equals x squared plus y squared minus 1. So what is a direction field? So a direction field is basically, what if you took every point on the graph and then found the slope of that point and then you plotted all of that. So that's what we have here. And to find the slope of each point, you just plug in the x and y values into the equation and see what you get. So for the point 2, 0, it would be negative 2 squared plus 0 squared minus 1, which ends up being 3. So our slope at negative 2, 0 is positive 3. And so we do this for every point on the graph and then sketch it all out. And then part B says, use part A to sketch the solution curve that passes through the origin. And so what I did here is redraw the graph, and now we have to look at the origin and how it interacts with the entire rest of the graph. So we see from up here that at the origin it has a negative slope, but as you move to the right, it curves upward. So that's what we draw here. And now we have to do it from the left. So we start at the origin again, and we see that it goes up from here and then down again. So that's what we draw here, going up and then down once it reaches the origin and then going back up again. So yeah, that's basically it. So to find the direction field for any equation, you just take x and y values, plug them into the derivative equation that you get, and then plot them all out on a graph. And if it asks you to sketch a solution curve that passes through a certain point, you look at that certain point, and then you just kind of follow the direction or the flow of each slope that you drew.